Howdy folks, today we are going to do some more live modeling. I'm looking at doing a tailstock die holder today. This is something I've made before, but I wanted to remodel using just kind of better practices here. So I thought I would go ahead and knock through this, and hopefully you enjoy it. So off the top, this one is parameterized out in inches, and because it will be interacting with objects in the real world, we're going to have some clearance. So this this die holder has two different sizes, so we're going to have a big side and a small side. So one of them is one size is 1 7/16. Add our clearance. And then we do a little bit of trigonometry to find where our points are. And our depth of this particular set is 1/2 inch. And then the small ones are 1 inch. And let's see, we do our trigonometry again. And the depth on these is 3/8 of an inch. So then this thing will be designed to work on an axle that is 1/2 inch. Alright, and let's see, what else do we need to know? The overall length of this thing is going to be 4 inches, and the diameter is going to be 2 inches, and this will make sense later, but I want to be able to machine this at some point in the future. The initial draft will be 3D printed, but we're going to do a 1/8 inch end mill, which will make sense when we're making the pockets later. So let's start with let's see. Actually, one more thing I want to define is the center section. I want to be 1 inch. So we'll start by doing a cylinder. So let's see. Actually, let's define our chamfer as 1/4 inch. See if that's going to work. So we'll do a cylinder. H is chamfer, and D1 is body D. D2 is body D minus 2 times chamfer. What does that give us? Let's see. You're not supposed to be in brackets. There we go. Alright, so that's a decent start. However, that is upside down. Should go that way. 1/4 inch might be a little extreme, but let's see. Let's see how it goes. Okay, and then on top of that, we need another cylinder. This is not going to be body H, but we want to see what we're looking at here. Okay, so that's not too terrible for the chamfer, I suppose. The printer should be able to handle 45 degrees there. Okay, now for this next section, this should really be, so we've got the full body here, which is going to have a cutout in it, like here. That's going to be the 1 inch, with 2 more chamfers there, and another chamfer up at the top. So a total of 4 chamfers and 1 inch here. So the height of one section here should be the whole body minus 4 times chamfer minus the body center, and then all of that over 2, because we have 2 of these segments. So it puts me about there. Now we'll see how this works out in the long run. Alright, so now let's keep some notes so I can see what I'm doing. Then next we'll have the okay. This should be let's move this whole thing out because we're going to use this a few times. Let's put this up here. Call it that. Grip height. Okay, so now if we go to above the grip and above the chamfer, and we do another chamfer, and this time we do want D1 equals body D, and D2 equals, let's do this as well. Let's make this the small diameter here. Just save that. Or let's see, I bet I could just do that because I used the word small before. Okay. Stick it down there. Okay, so what do we have here? Oop, that didn't work. What did I screw up here? Oh, I still left, let's see, body D minus 2 times chamfer, that's okay. Ignoring another arrow. No, because I put that before chamfer was defined. There we go. That's more what we're looking for. Okay, and as I'm playing with it, I think this chamfer may be a bit much. Let's switch that up to 1/8 of an inch. It's alright. Let's see, maybe 3/16. Yeah, I think I like that. Alright. So now we'll do the center. And this needs to go 2 times chamfer plus the grip height. And then this is a cylinder that is as tall as the body center, and its diameter is chamfer D. Alright. Then we have body top chamfer. Okay, then we need to go this whole height plus body C. And now we're going to do another chamfer like the one on the bottom. That one. Wrong button. Okay, that gives me the chamfer there. And then we'll do the top body, which will look a lot like this, but we're also going to add in another chamfer. And then this will look like the body section. All right. And let's see. Then we want to do the top chamfer. And we'll just keep adding to this. And this should look like the top chamfer here. Whoop, or not. There we go. Flip that guy over. All right. So now we have our overall shape here done. And let's see. Let's wrap this into a module. Okay, and then we are going to, oh yeah, should really give this thing a name. Module body, all right. We are going to start subtracting things from this. So let's see, let's start with the axle. So this should be a cylinder where h is equal to the body height and d is equal to the axle d. Okay, and here let's actually do a render so it's clean. Then you can see that we've punched a hole clean through, so we can run our axle. All right, now the next thing we're going to do is we're going to subtract the, let's see, the big die pocket. So if we were just printing this, let's see, yeah, all right, we could just do h equals big H, d equals, and this would be the points. And then do a fn equals 6 to get us what we're looking at here. Oop. So you can see that that cuts in here. Let's see, that's getting a bit into our chamfer. Our chamfer might be a little bit too big here still. Let's see. Let's knock this back down to 1/8. See how that works. Render that up. All right. Yeah, that's a little bit better. We're at least not running into our chamfer there. All right. So, but you can see these sharp corners here. Now we can print these, and the actual dies are rounded enough in the corners that it's not going to be a problem coming up into this area. The actual die will round over like this. But this is not a shape that I can cut with an end mill. The end mill has at minimum a, I'm looking at a eighth inch diameter cutter, so I'm looking at a 1/8 inch that I have to live with here. So let us get a little more complicated here. So we're going to make another module here. Let's see, actually, before we do the hex pocket, that's going to wind up having to build on something else. Let's start with a bolt circle. So this is a pretty common machining operation where you define the number of holes you need, what the diameter is, and how deep they go. And what it does is you wind up making a circle of bolt holes. And in our case, they're going to be the points of the hex here. So there's going to be one here, one here, one here, one here, one here. This will all make sense in a minute. Okay. Do some more trig. This is where our end mill diameter comes in. And here's our actual cylinder. Okay, so this is our bolt circle. And then let's see if I can demo what this thing looks like. If instead of doing this, we do bolt circle, and instead of our Fn equals 6, we just give n equals 6. Let's see. What did I break? Forget that. Alright, let's see. Okay. Alright, so you can see we've got a circle of bolt holes here. We'll need to, let's see, should probably increase our resolution here. So you can see a little better what that's going to look like. We're off into our chamfer. We'll play around with that a bit in a minute. I'm not sure my trig is right here, but let's get back to the rest of the hex pocket, and then we'll go back and fix it if we need to. Okay. So now to do this, we will have let's see, d equals d times 2 over square root of 3. H equals h, and Fn equals 6. So start with that guy, and then we will tack on a bolt circle of d, h, and 6. So if we do that, then we come back down here, and we get rid of bolt circle, and instead put in a hex pocket. Just needs D and H. We don't need to give it n equals 6. And hit that up. And let's actually render that up. Rendering. Come on. There we go. Okay, now we can see what we're doing here. And that is looking like we're might be cutting into our chamfer a little bit much. Okay. While we're here, let's look at the small die pocket. Oh, I know why. Because this shouldn't be big points, this should be big flats. Re-render that. Look back at that. There we go. Now that's what I would expect to see. So you can see we can actually cut this with the end mill here. Come on, positioning. So the actual tool path will come up like so, then it'll go up into the corner, and if you would follow this line straight, it would actually meet right at the corner here. So this winds up making a hex pocket that you can cut with an end mill, where the corner is still where you want it to be. And yeah, so that's what that'll look like on the finished product. So for the small one, we need to move it. Let's see, we need to move it up nearly to, let's see, we want to move it, actually we just want to move it the whole height minus its own thickness. So we could do, this would be body H minus small h. So that should just be whatever the thickness is, and then this is hex pocket small h, d equals small flats. Do that, render that, and that didn't work. Oh, it's because I can't spell translate. Alright, do that, render him again, and there we go. Now we get the small pocket up on top. Alright, let's see here. Now I think there's one more thing that I want to do in order to be able to actually print this. So, let's see. for printability here, I think I want to switch the top and the bottom. So let's stick this one here. So if we do that, that'll swap those two. So now the big one's on the top, little one's on the bottom. We still can't print this upper surface in here, so let's play around with this a little bit and see if we can put in something to smooth this out. Let's try. We're going to stick a cylinder in here up above the actual pocket for the die. And what we need this to look like should be, let's see, H should be, let's see, minus axle D, divide that by 2, cylinder, H equals that, and D1 equals small points, and D2 equals axle D. Let's see, can we fit this all in one line? No, of course not. Alright, we'll go back to that. Alright, render this. Thinking. Okay, and now if you look up in here, you'll see that we've got a 45-degree gradient going on up in here. So that's an angle that the printer should be able to handle. And it just comes up from the wall here. So that should be printable at this point. So yeah, I think that's about gonna do for this model here. I could smooth it out, do like a, FN equals 100 or 360 or whatever to get it smoother, but you actually want some grip on these. So yeah, we'll sort that out in a couple of drafts. And like I said, I'm going to print this out of plastic, and we'll see how well it works. And if I like it, I'll probably cut it out of a more interesting material, but we'll figure that out later. So I guess I'm going to finish up here just by showing you the print, and then maybe a couple of pictures, and that'll do for today. So thank you as always for watching, and we will see you in the next one.